This is the sample value which is changing very slowly. Here you can see that this value is also changing here in my trainer when I am changing the value of signal. This is the analog value of my signal, and this is the digital value of my signal. Bismillahirrahmanirrahim. Assalamu alaikum. How we convert a signal from analog to digital and conversely from digital to analog. This is a very important feature in PLC programming. You need to stay tuned with me till to the end of this video so that you can learn everything. What are the main steps, how we can convert a signal from analog to digital and from digital to analog. So stay tuned till to the end of this video. Before proceeding further in this video, please subscribe my channel so that you can get a notification for every new video. Here I have constructed a ladder logic program for conversion of a signal from analog to digital and digital to analog. First of all, you need to understand that how we convert a signal from analog to digital. For this purpose, we need to understand its theoretical details. So first of all, I discuss its theoretical details. When we have an analog signal, this is an analog signal. The first step to convert an analog signal to the digital is sampling. First of all, we will take samples of a signal. So these are the samples. Let's suppose this is a signal from 0 to 5 volt. This is the one sample at 1 volt, second one at 3 volt, 5 volt, 4, 3 and 1. And in the negative side, you can also take samples. After taking samples, the second step is to take its average value. So I will add all the samples, its voltages, and divide by the total value. So this is the 17 divided by 6, 2.8. This 2.8 is the average value from which we will cut our analog signal to convert it to the digital value. So analog signal will be, I will cut it here. This is 2.8, this is the 5 volt, this is 0 volt. So this looks like to be 2.8 volt. So this signal is, I will cut it here. So you can see that this is the digital signal which I will get after conversion of analog to digital conversion of a signal. So this 2.8 volt will represent the 1 and the 0 volt is already 0 volt. So this is 0, this is 1, this is 0, this is 1 and so on. This is a digital signal. Now conversely, how we convert a digital signal to the analog signal. This is my digital signal and I will convert it to the analog signal. So for the conversion of a digital signal to the analog signal, we need the present value. This is the present value of the signal. This is the original value or the present value of the signal. We will combine its digital and the present value. This is its analog value and this one is its digital value. We will combine it, and those samples which are not present here will be inserted from its present value. So these signals which are above 2.8 volts, which will be inserted in this digital signal to make it analog again. After inserting these signals, you can get its analog value again. So this is 0 volt, this is 5 volt, and this is the analog signal of my signal. This is the original signal or the analog signal. In this program, we will discuss some instructions. First instruction is to instruction is used to transfer a data from PLC to the buffer memory. Buffer memory is the memory of analog to digital converter or digital to analog converter, whichever you have selected. The buffer memory represents the memory of converter, analog to digital or digital to analog converter. And the from command is used when we move a data from buffer memory to the PLC memory. In the same way, here are some memory locations which will be used in this program, and you need to learn these memory locations. Hash 1 to hash 4 are used for sampling, and in program we will write it as K1, K2, K3, K4. And hash 5 to hash 8 will be used for taking every value. In program we will write it K5, K6, K7, K8 and so on. Hash 9, hash 10, 11, 12 are used for the present value. In program we will write it K9, K10, K11, K12 and so on. In this way we can convert a signal from analog to digital and digital to analog. So going towards our program, we will discuss that how we can convert a signal and how its value will be changed. Here is my program, ladder logic program. In this program, first of all, I have taken a rising edge of X0 input. When this is turned on, it will provide a single pulse which will turn on this instruction. In this instruction, first thing is the instruction command. This is 2. I have already discussed that the command 2 is used to transfer data from PLC to buffer memory. First entry in this output instruction is the module, analog to digital or digital to analog converter module. If I have placed analog to digital converter at the first place, K0, it will be selected. If I have placed digital to analog converter at first place, 0 place, it will be selected. So I have placed on my trainer analog to digital converter. So this is the analog to digital converter. This is analog to digital converter, analog to digital converter, and at last this K1 is the second converter, which is digital to analog converter. The second thing in this instruction is buffer memory. This is K1 is buffer memory, K1, K2, K5, K6, K9, K1, these are the buffer memories. I have already explained that how these buffer memories work. And the third one, K500, D0, D1, D10, D12, D12, these are the memories of the PLC. These are called PLC memories. And the fourth one, K1, 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 this is called the channel of my analog to digital converter or digital to analog converter. So I will discuss in detail here how these channels work, why these channels are selected. If I am taking my signal in voltage, which will have its voltage value 0 to 10 volt or plus minus 10 volt, then I will select its first channel, K1. So here you can see its detail. Is I have already discussed that these are the buffer memories of my analog to digital or digital to analog converter. First one is hash 0, which is called K0. It is the channel selection. Hash 1 to hash 4, it means that K1 to K4 are used for selecting samples. This is used for selecting samples. From 1 to 4096 samples can be selected at a time. Hash 5 to hash 8 I have already discussed. These are used for taking every value. Hash 9, hash 10, hash 9, hash 10, 11, 12, these are used for taking present value. And other memory locations, everyone have its own specifications. Hash 15, selection of analog digital conversion, speed. This is used for speed. Normal speed is 15 millisecond, default speed, and it when set to 1, a high speed is selected of 6 millisecond per channel. Hash 16, 19 are reserved. Hash 20 is reset to default and preset, and everyone offset, adjust gain value, reserved. Error status H29 is used for error status, identification code H30 and 31. H0 to H31, these are 32 memory locations of analog to digital converter, which are used for different specification, different characteristics, different selections. And one other very important thing is that we have 4 channels on our analog to digital converter or digital to analog converter. These 4 channels are selected in this way that it's channel 1, if we are taking signal in the voltage value, then we need to select channel 1. From minus 10 volt to plus 10 volt in its range, you need to take analog signal in this range. Going beyond this range will definitely trouble your analog to digital converter and will ultimately create a fault for your analog to digital converter. Second channel is used for plus 4 milliampere to 20 milliampere signal, current signal. When you are taking your analog value in current, you need to select this second channel. And the third channel is used for minus 20 milliampere to plus 20 milliampere. When you are taking your signal, analog signal in this range, you need to select the third one of your channel. And the fourth channel is channel off. It is not used for anything. It is channel off. For example, we have H3310. This is channel selection. It means that here is channel 1 is used for minus 10 to plus 10 volt. Channel 2 is used for a flow plus 4 milliampere to 20 milliampere. Channel 3, channel 4 and channel 3 are selected here off. Because I have already discussed that these channels are used for different kind of voltage and analog values. This is a channel selection H3310. 3 means channel 3 and channel 4. Here is channel 4, channel 3. Channel 3 and channel 4 are selected off, and 10 means 1 mean present channel 1 mean I am taking plus 4 milliampere to 20 milliampere at channel 2, and 0 mean I am taking minus 10 volt to plus 10 volt at channel 1. This is the channel selection which is represented here. In this way you can learn the channel selection. Now I am going towards my program and will implement that how we can convert a signal from analog to digital value. When I turn on this switch, this 2 command will operate, and it will transfer, it will take, this is the analog to digital converter, this is my buffer memory, this is PLC memory. So signal will come from buffer memory. This is buffer memory in which I have taken 500 samples, K500 sample. This is my PLC memory. When I operate this, I will turn on this, a single pulse will be transferred to this output, and 500 sample will be transferred from here to this K1 using the channel K1, because I am taking my input signal in voltage, therefore I am using my channel K1. So when this turn on, this is the same thing, it will also be turned on, and here from command will operate. From mean signal will come from buffer memory to PLC. This is buffer memory, this is PLC. At this I have taken 500 samples, and this is the buffer memory. From this using this from command, these 500 samples will be transferred to D0, which is the PLC memory, using the channel K1. And again from command will be operated. K0 is the first module, which is analog to digital converter. K2 is the buffer memory. In K2 I have not placed any selected samples, therefore by default it will take 8 samples. If we have not defined how many samples we are taking, it will take by default 8 samples and will place it in D1, which is the buffer memory, which is the memory of my PLC. D1 is a register, D1, this is the memory of PLC, taking the channel K1, which is voltage channel. So when I select X1, from command will be operated again, my analog to digital converter will be used, and K5 means hash 5. I have already discussed that from hash 5 to hash 8 are used to take the every value. So this hash 5 will take the every value of those samples which are present in analog to digital converter and will place this every value in D10, which is my PLC memory, and using the channel K1. And again from this command and using analog to digital converter, hash 9, I have already discussed the hash 9 to hash 12. This is K9 to K12. K9 to K12 will be used for taking present value. So I have used K9. I can also use here K10, K11, K12. This K9 is used to take the present value. So it will take the present value of the samples, or present value of the signal, which is present in the K0 analog to digital converter, and will place it in the D12 register of the PLC using the channel K1. And again from this to command, signal will be transferred from buffer memory to PLC memory. This is the buffer memory. From 2 it will be transferred from PLC memory to buffer memory. This D12, at this D12 register I have placed K9 using present value. So present value is present here, and here I am using, this is very important to notice that K1 is here, K0, 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 but here I am using K1. This K0 was analog to digital converter, and this is K1, which is to the digital to analog converter. So this D12 have the value of present value of the signal. So by using the to command, this present value will be transferred from here to K1, which is the buffer memory, which is the memory of digital to analog converter. So this analog value will be, this is the to command, which means that it will transfer its data from PLC to buffer memory. It will be transferred from PLC to buffer memory. So here you can see that it is also using the channel K1, which is the voltage channel, from minus 10 volt to plus 10 volt. So this present value or the analog value will be present here in D12 register, which will be ultimately transferred to analog to digital to analog converter K1 at its memory location K1. Because this to command will transfer this analog, its present value of the signal to K1, which is the memory of this digital to analog converter. In this way we will get analog signal here. It means that using this K5 you will get digital signal here. Using this K9 you will again take its present value, and using this K1, this will be transferred, present value will be transferred to the digital to analog converter, and in digital to analog converter you will get its analog value here. So first of all I will convert this program, going to online, write to PLC, program plus parameter, execute, yes, yes, yes. This program is now transferred to my PLC. Going to monitor mode to observe its values. you can see that when I turn this on, a single pulse will be transferred from here, and these 500 samples will be taken and will be stored into buffer memory. This is the buffer memory, this is the PLC memory. I have taken 500 samples and will be stored here, which is the memory of analog to digital converter. So I am clicking it on yes. You can see that 500 samples are taken, which are transferred here. 500 samples are taken because I am using K1 hash memory. I have already discussed that K1 to K4 are used for taking samples. So using this memory location, these 500 samples are taken, and when this is turned on, these are the same switches. Then this is turned on. Here I am using the from command. This from command will transfer these samples which are present at this location. At this location will be transferred to D0 register of PLC. These are the 500 samples here in PLC. And in the second step, second line, I have not defined how many samples I am taking. This is K2 memory location. K1 is also used for taking samples. K2, K3, K4 are used taking the samples. Here I am taking K2, which is also used for taking samples. But I have not defined how many samples are present at K2 because I have not transferred samples like this. 500 samples are transferred to this location K1. Here no samples are present at K2, so it will by default take 8 samples and will place in D1 register of my PLC using the channel K1. In the same way, when I turn on X1, this is using the analog digital converter, and K5 I have already discussed that K5 is used to take the digital value or the present value. It is used to take the average of the samples. It will take the average of the samples which are present in K0 analog to digital converter at the location K1. It will take the average and will place it in D10 register of my PLC. So when I turn this on, it have taken its present value, its average value or its digital value. This is the digital value of my signal 2060. And again I am using K9, K0, K9, D12, K1. K9, K10, K11, K12 I have discussed that these are used for taking the present value. So K9 will take the present value of the signal of the analog to digital present in the analog to digital converter and will place it in the D12, which is the present value of the signal. So present value will be here D12, its digital value will be here in D10, and again I am using the to command, and here I am taking the digital to analog converter. This is my digital to analog converter because this is K1, K0 analog to digital converter, and K0 is analog to digital converter, K1 is digital to analog converter. Here it is using K1. It is here I am using the to command, which means that data will be transferred from PLC to buffer memory. This is the PLC memory. Data will be transferred from here in buffer memory K1. I have placed D12 with the present value of the signal. So present value will be transferred from here, which is the memory location of K1. It means that it is digital to analog converter. So this present value will be transferred to the digital to analog converter, and this value is the analog value of my signal. So I am changing my value. You can see that by changing the value of my voltage signal, its value will be changed instantly. You can see that this is the analog value which is changing very fastly, but this is the digital value which is changing very slowly, because I have taken 500 samples. If I increase my samples, number of samples, this value, the change of value will be very fast. Therefore, if number of samples are increased, the accuracy of the signal will be increased. You can see that this value is changed here from after taking some time, because I have taken 500 samples. When I increase my number of samples, you can see that I'm here going to write mode and increase my samples, number of samples. I will take here 5,000 samples. Okay, I will take here 3,000 samples. Convert online, write to PLC, Analogue program plus parameter. Yes, this program is loaded to my PLC. I will go to monitor mode and check it. You can see that these 3,000 samples, by changing its analog value, you can see that its digital value is also changing. This is my analog value or present value. This is the analog, this is the present value, this is the analog value, and this is my digital value. I can show you again that by changing my analog value on the meter, I have placed both of my meters are this is the sample value which is changing very slowly. Here you can see that this value is also changing here in my terminal. When I am changing the value of signal, this is the analog value of my signal, and this is the digital value of my signal. This value is same almost, but it changes after taking some time because I have taken fewer samples. When you increase the number of samples, its value will be increased very much. This is my PLC, and this is the extension input module, this is the extension output module, this is the analog to digital converter, and this is the digital to analog converter. If you have placed at first position analog to digital converter, this K0 is analog to digital converter, and after selecting K1, the second converter will be selected, this one, which is the analog to digital converter. So it will work in series. This is K0, this is K1, after that K2, K3 and K4 and so on. You can place many analog to digital converters with it. So in this way you can select a signal in analog form. I have selected my signal in voltage form. This is the voltage signal. This is the signal which is changing when I move its voltage value. This is the analog value and this is the digital value. I have placed here digital meter to read my analog value, so you need not to confuse that it is a digital value. It is analog value, but the meter that I have used here is digital to show its value on screen. Analog value of this is the knob of my voltage. You can understand that voltage is an analog signal. When voltage increases or decreases, its value will be increased and decreased here and there. In this way you can understand that how my PLC can convert a signal from analog to digital value and from digital to analog value. Thank you so much for watching this video.